the data-driven and responsibility-driven design. Let's start with the data-driven design. Have you ever wondered why social networking sites like YouTube, online shops, or any other online platforms knows what to recommend when you visit their websites? The truth is, the websites or these websites uses an approach that collects data and use it as the main source for making decisions, and it's called the data-driven design. Just like what Steve Jobs said, it's really hard to design products by focus groups, and a lot of times, people don't know what they want until you show it to them. So in general, class, data-driven design is a type of approach wherein we collect data and use those data in order for us to give a good user experience to our customer. Okay, whether it's an app or an application or a website. So since we're going to collect data, we need to know what data to use. So there are different kinds of data to determine the best way to create a good user experience. This data can include things like website or an app analytics on an existing iteration of a product, user interviews, A/B, and multivariate test results, behavioral flows or behavior flows, and other types of user experience research. So here we have the user experience data collection technique. So it's composed of the design analytics, A/B testing, multivariate rate test results, behavior or behavioral flow, and user research. Okay. So methods for data gathering. So the first one is the design analytics. So it is a method for developing analytics solutions that enable business strategies and drive measurable business impacts. So most of the time, class, in design analytics, it is composed of people wherein they solve certain problems that the company or the business is encountering through the use of interviewing or getting information from the client or their customer. And then they're trying to find out what problems, what are the flaws of that application or website that they're using. Okay, so that's the design analytics. So they are trying to check what are the problems, what are the flaws of the current system in a company. Okay, and then try to solve it, and then conclude what are the problems and the solutions that will be implemented in order to avoid those problems or solve those flaws in a company. Okay, so the next is the A/B testing. It is a method of website optimization in which the conversion rates of two versions of a page, say version A and version B, are compared to one another using live traffic. So A/B testing is useful in evaluating page design. Okay, so in A/B testing, we have two versions of a program, and then we try to find out which of these versions is better than the other. Okay, or which one of these versions is the best. For example, we have these two designs. Say for example, here's the original design. I'll just try to annotate that. Let's just say this is the original design. Okay, wherein the buy now is color gray. Okay, so we want to know if the users or the customers will click the buy now, which is a gray, or the buy now, which is color red. So we have two versions, the original and the proposed new variant or new version of that application. So if the original has the most number of traffic, then definitely we will still implement the original version. But if the new version has the highest rate of traffic, let's say for example it's most likely more customers click on this button which has a red buy now button, then definitely we will implement this kind of button onto our system. Okay, so that's the A/B testing. So we want to consider, or we want to decide which of these versions are are approved to our customers or to our clients. Okay, so that's the A/B testing. So how about the multivariate test results? So uses the same core mechanism as A/B testing, but compares a higher number of variables. Okay, so it reveals more information about how these variables interact with one another. Here we have the headline test or headline to test, and also the image to test. So for example, in our version 1, we have this gear icon, and then plus the header or headline to test, which is yung ACME widgets. Okay, so and then the version 2, we're going to replace this with a bulb or a light bulb, and with the headline of ACME widgets. Or the third version is we still have the gear, and then the headline to test is the one and only ACME widgets. Or version 4, we have the light bulb plus the headline, which is the one and only ACME widgets. So we have multiple variables here that we are trying to compare, and which of these versions has the higher rate of traffic, then definitely that would be implemented in our website or application. So that's multivariate test results. So the next one is the behavioral flow or behavior flow. So it is a report that visualizes the path users traveled from one page or event to the text or to the next. So this report can help you discover that content keeps users engaged with your site. So the behavior flow reports can also help identify potential content issue. So Google Analytics is one example of a website that offers behavioral flow report. So if your product's a website or app, tools such as Google Analytics are a great source of quantitative data. So we count the number of clicks or click-through rate, bounce rate, or etc. So to help you make decisions. So you can visit their websites here using this link, and then try to search or read their articles about the Google Analytics and how it works. Okay, so once we click, it's like a in YouTube, wherein once we click a video, it adds up the number of views and the number of likes. So when we click like, then definitely it will add up to our viewable content. Okay, so that's the behavioral flow. We also have what we call the counting of number of clicks, wherein we have the click-through rate. So wherein we check how many times the website or the page or content of a website is being clicked, how many visits. Okay, so that's how behavioral flow works. And then the next one is the user research. So this method includes the contextual interviews with actual users, focus groups, surveys, and heuristics or heuristic analysis. Okay, and then user research is one of the more resource heavy methods of data collection, but can also be the most valuable. Okay, so especially for new projects and products without existing primary data sources. Okay, so when we say user research, we conduct face-to-face interviews on different users or focus groups, or giving surveys or heuristic analysis, wherein we rely on those data that we gathered from the different users. I think this is more accurate, but sometimes it's more it gives you a lot of work in order for you to gather those data and user research. Okay, but can also be the most valuable, just like what it said in our slide. Okay, so if this is a new project, then definitely user research is more I think this a good method for data gathering, especially for new projects. Okay, so after gathering those data, how do we analyze it? Okay? So collecting data is only one aspect of the data-driven design process. So quantitative data such as design and UX analytics is vital, but qualitative data like that collected from user interviews is just as important, if not more so. Okay, so quantitative data gives designer an idea of what is happening on a website or an app. But qualitative data is needed to shed light on why users, what they do, and figuring out why users behave in certain way is a large part of the UX theory and the psychology of the design. Okay, so there are differences in quantitative and qualitative design. So in quantitative, we measure the quality of a design through numbers. Okay, for example, number of clicks, number of views, number of likes. But in qualitative, we're trying to analyze the comments and the contents, the pros and cons of a product or of a website. Okay, so it's more on an interview or survey wherein the user gives its opinion or suggestion based on what he or she experienced on our website or services. Okay, so that's the difference between the quantitative and the qualitative data. Okay, and once both qualitative and quantitative data has been collected, designers should look for trends in the data as well as the outliers. So outliers can give insight into potential problems that users may run into and that could become significant as traffic numbers increases. So when we say outliers, so it is a data or thing that is differing from all other members of a particular group or a set. So data should be analyzed on a continuous basis as new data is collected. So we need to update our data or information that we have collected every time that there's a new data coming from our users. So design changes, content changes, changes in search engine algorithms, and other developments can all affect user experience and user behavior. And designers can analyze this data to constantly improve and make new iterations of their product. So it's a never-ending process of developing our system. So that's why, as you can see in our applications, there are different updates wherein a new feature or a new design is being implemented in our applications. Just like in Facebook, I think last year or 2020, it changes its theme into something more like it offers a dark theme, and its design is completely different from the first one. Okay, so now how do we present those data? So in addition to analyzing the data, presenting it in a project is often important to getting them to buy into the best design solutions. So displaying data visually is one of the best way to present information. So, well, of course, after analyzing the data, we have to present it and then show it to our customers or to our group if it's the best solution for our problem. And also it's a good way in order for us to present the information that we have so far in giving a solution to a problem. Okay, so here we present data in order for us to have some discussion with our team and our client, so in order for us to make a better solution for our websites or applications. Okay, so that's the purpose of presenting the data. And then creating a slide deck with charts and graphs can often make the difference between getting a client or manager to approve a project and facing resistance at every step along the way. So data can back up a designer's intuition about the right design choices to make. So, well, of course, we have to get the suggestions or idea of the client or manager, and also to be approved or to get an approval to our manager in order for us to go on with our designs. Okay, well, of course, before implementing a design to a website or application, you have to consider first the insights of the manager and the client, if that's acceptable or not, or if it really solves the problem in such a way that it doesn't cause much trouble or much um, much time in creating or having some difficulties in doing uh, the new design for our website or application. Okay, so that's the data-driven design. It's all about collecting the data and analyze those data and then implement some solutions to our given problem based on our data. So it's a never-ending process. Every time that we collected a new data from our customer, we analyze it and then implement a good solution to that. And then again, if we encounter problem, get some data and then implement a good solution again. So it's a never-ending cycle, a never-ending iteration of improving your application or websites. Okay, so that's just the that's all about the that's for our data-driven design. Okay, so next is this the responsibility-driven design. So that now that we know how to collect data using different techniques in data-driven design, so it's time for us to dig deeper on how this data is implemented in a system. Okay, so as stated on the name of this design, so responsibility-driven design or RDD expresses the idea that each class should be responsible for handling its own data. So it's more like a design used in object-oriented approach of programming. Okay, again, so responsibility-driven design expresses the idea that each class should be responsible for handling its own data. Okay, so what are the data that this class should only have? For example, we have a number class, then definitely that class could only handle numbers or integers or floats, which are decimals. Okay, so that's the responsibility-driven design. So ideally, this design focuses on what role or capabilities a class should have and which data it should handle. Okay, not sure that's has something to do with the cohesion and coupling design last module, wherein a class should only have uh, its own capabilities or set of capabilities which is applicable to that given class. Okay, so what role or capabilities a class should have and which data it should handle. Okay, so an example of this is when we created an object of class bank, and this class should only have manage account, get balance, set balance, and other related methods or behavior. But this bank shouldn't have display or print since it's not part of the job of a bank class. Okay, so a separate class should be created for displaying the balance and other account details as well as printing the transaction details. I think this more likely related to the cohesion, wherein we're specifying or giving a class a limited number of designs, I mean limited number of behaviors or functions which is only related to that class, okay, to the class itself. Maybe you could go back to our module 3 and check the cohesion. I know it's cohesion, definitely it's cohesion, wherein we assign functionalities based on the name of the class and what are the data that it could handle. Okay, so that's the responsibility-driven design. And that's all for our data-driven design and responsibility-driven design. And I hope that you learned something new from this different techniques in data gathering and why do we gather data, and also the responsibility-driven design, which is explained in a much more explanatory way here in our last slide. Okay, so thank you and God bless.